Guys, welcome to today's lesson. We are going to look at computer networking. This is very important because it allows us to understand how we are able to exchange information, communicate, and even access the internet through the devices that we have access to. So we are going to look at a few things, and the objective is by the end of the lesson, you should be able to define the terms related to computer networking. You should be able to mention the devices we use for computer networking. You should be able to explain some of those ways in which we can network computers and other devices. So without wasting time, let us start with the definitions. And the first one is computer networking. This is basically the practice of connecting computers together to enable communication and data exchange between them. Then a network is a group of interconnected nodes or computing devices that exchange data and resources with each other. So whereas networking is the process or that practice of connecting those devices, a network is those devices now specifically. So what are these devices? These devices are basically electronic devices that can process, store, retrieve data, and can perform calculations or other operations. And examples are like switches, computers, laptops, desktops, hubs, radios, and so on. And then we can now look at a few of these types of networks. Number one is a personal area network. And as the name suggests, this network is personal in the sense that we are only connecting a few personal devices. For example, we can connect a phone, a laptop, we can connect a printer, we can connect a mobile phone, and so on. We can use technologies like Bluetooth to connect a few of these personal devices so that somebody can access the laptop from one room, can send a document for printing in the other room, can listen to music in the kitchen, for example, and so on. So as you can see, the network is only meant to serve personal space. And because of that, because of the aim of the network, because of the aim of that network, therefore, we also acquire the name from there. And that therefore, this one becomes what? It becomes a personal area network. The next is the local area network, which is now localized. This is basically a collection of devices connected together in one physical location. And this is, for example, a building or an office or even a home. So in this one, you can see the devices have increased in number. The technologies have also increased. And therefore, as you can see, that we are having a router accessing the internet, and then this router serves the server, and the server computer allows the nodes. It allows all these computers to also access that same internet. This is important because in this case now, for example, in a school, different offices scattered over in the compound of the school can be able to process information, can be able to send this information to the server. They can also be able to access information stored somewhere on the internet through this kind of arrangement that therefore we refer to as what? As a local area network. Then next, we look at a metropolitan area network, and you can guess. Can you guess what that does? Metropolitan refers to a city or two, a locality. No, so in this network, we are having different offices, residential areas, we are having government buildings, industries present in that city or town, all accessing the internet and its resources, but through this single network that we are therefore referring to as a metropolitan area network. So remember, this one we are talking of a city or two cities. For example, we are able to serve a city or two using this single network that we are calling MAN, short for Metropolitan Area Network. Lastly, we can look at a wide area network, as the name suggests, wide. So this is wider than the metropolitan area, whereas that serves two cities or less. This one serves more than two cities. We can have different geographical locations scattered over, but each of those geographical locations can access the internet through a single network that connects them. That is important because in this case, you realize that we are able to serve different areas that are geographically displaced. Far away places, for example, but all of them can access this internet resource through this network that we are calling the wide area network. Then next, after looking at the networks, we can now look at the arrangement of computing devices within this network. What do I mean by this? It is referred to as a network topology. That arrangement, the pattern or hierarchy in which the nodes are connected is referred to as a network topology, and we have several. We shall start with the bus network topology, where each node is linked to only one other node, and the communication only occurs through one single pathway that we refer to as what? As a bus. We shall look at the diagram representing this bus shortly. Next is the ring network, where each node is linked to two other nodes, thus forming a ring. So the computing devices are connected in such a way that the pattern formed is a ring. Next is the mesh network. As the name suggests, mesh. So we are having several nodes, and each one of them strives to be connected to every other node in the system. By doing so, the interconnections, the many interconnections, end up creating what we call as a mesh. Next is the star network topology. You can guess from the name star, it means that we have a central node. We have other nodes scattered around, but we have a central node that serves as the mediator. It is the intermediary of communication, coordinating all business between all the other nodes. So we are also going to look at all those diagrams representing these topologies, so that we can have a deeper understanding of what we are referring to. And we shall start with the star topology. Star topology, you can see we have a central node here, which helps us to visualize this star. Then we have the other nodes connected around that network, that central hub. So if this computer intends to print something on this printer, there is no direct connection, only through the central hub. So the computer will send the data through the central hub. Then the central hub will direct that same information to the printer, and that information will be printed out. If this computer intends to communicate to the other computer on the other side, it will send that information through the central hub, and that information will be redirected to that computer on the other side. So as you can see, we are having communication, but this communication only follows one pathway. That information must pass through the central hub. What is the advantage? The advantage is that information control is very smooth. You will not find an unintended communication occurring between A and B, except that redirected by the central hub. The only disadvantage is that if the central hub breaks down, communication breaks down, and no more interchange occurs between the different nodes. The next is the bus topology, where this is what we refer to as the bus. This single conduit you are seeing here is the bus. Then each of the nodes are arranged in that manner, each one of them connected to the bus, so that if, for example, this computer intends to print something on the printer, it will have to send that information through the bus, and the bus will therefore redirect that information to the printer for printing. This one also has a disadvantage in the sense that if, for example, the bus fails, then no more communication occurs. Why? Because that is the only channel of communication that is present. So if it fails, no more communication occurs. So that is also a disadvantage in the bus topology. Then the ring network, as you can see, we are having a ring. The nodes are arranged in a ring type manner, and therefore if this computer intends to communicate with this computer, then that information must be sent, and it will pass through this node before reaching that destination. So each node depends on the next node for communication. Now supposing this node fails, can you guess what happens? There's no communication between the other two nodes. So that means that this one also has a disadvantage in a way that if one node fails, then communication fails. Why? Because the channel of communication will have broken down. So there is no more pathway for information flow to occur. Then we are having the last one here, which we refer to as the mesh network. As you can see, this is the mesh. we are saying that each node strives to be connected to every other node. So this is the mesh. Now this one is more stable than the others. Why? As you can see, supposing this node fails, what happens? The rest of the nodes can communicate. They can continue communicating because we still have communication channels. We still have connections between the other computers and nodes. So communication will continue. And this one is therefore more stable, more advantageous as compared to the other network topologies. So those are some of the examples we shall look at. We also have others like the tree network topology, which we are not going to consider in this series, where only one node exists at the top and the rest of the nodes are arranged in a hierarchical manner flowing down, so that that node at the top is the one that coordinates all communication. Now, let us proceed. We are looking at best practices for computer network management, and the first practice is always pick the right topology. Ensure you pick the right topology because this can either speed up or slow down your network. It can even break the network. So pick the right topology to ensure optimum performance. Number two, document and update constantly. Ensure you always keep an updated document so that you can be able to backtrack, you can be able to make references for when your network is down, for when your network is low, and for when your network is optimal. Number three, use the right tools for network management and monitoring. For example, IP address management, for example, data packet trace. You can be able to look at DHCP servers and firewalls and so on. Choose the right tools for your network requirements. Number four, establish a baseline. Have a reference point for when your network is optimal, for when you are experiencing abnormal behavior. This is important because it allows admins to know how the network is behaving normally, what is the traffic today, how many users are accessing the internet or the system, and so on. So these established baselines can be able to alert when anomalies are occurring and when we are having faults and when we are having breakdowns. Next is continuation of that. Always protect the network from insider threats. Use firewalls and intrusion prevention and detection systems, and so that to prevent bad actors from accessing that network. Today, people are very clever and they are now using social engineering ploys. They have realized that human beings are weak and therefore they can capitalize on their trust to access the network through people who have the right access. And once they are inside, they are able to attack the network and prevent anybody else from accessing those services. Then use multiple vendors for added security. Now, never, I repeat, never depend on one vendor for your security tools. You can get a switch from here, you can get a firewall from there, you can get your routers from here, like that, because different vendors implement different security features, and that is important. Once you mix this, once you put this into a coagulated form, you realize that your network is strengthened and your security is strengthened. That is very important also. And then segregate the network. By segregation, I mean divide the network into smaller functional units. How? This is important because you realize that supposing one small functional unit you have created fails, the network does not stop, people do not stop working, everything continues as normal except for that small functional unit that you can therefore go down and try to solve the fault. So that is very important also. And lastly, use centralized logging. Ensure you have a central log where you can always do analysis, you can always look at who is accessing what, who has logged in at what time, you can be able to spot overwhelmed system, you can be able to backtrack and see that the problem started from this point or this time of the day, and you can be able to sort that problem very easily. So a central log is also important. It allows you immediate access and analysis. So guys, that is all for today. Thank you for being with me. Next time we are also going to have another series to be able to look deeply into the techniques of how to implement these topologies, so that we can also be able to discover on our own the advantages and disadvantages of each one of them, and everything else that is a plus on optimal network performance. So that is it for today. If you have not subscribed to my channel, please do so and hit the notification button so that you are always number one on the list to get all the new updates that come in. So thank you again, and let's meet in the next episode.